Okay, in this lesson we'll look at how to write ionic equations. Now at this stage, when you are required to write ionic equations, you'll be given a balanced chemical equation. Okay, when you study further, you may not be given a balanced chemical equation. So if you are not given a balanced chemical equation, you are required to come up with a balanced chemical equation, and then from there write the ionic equation. Okay, let's assume that you are given a balanced chemical equation. Okay, let's start off with an example. This is an equation between HCl, hydrochloric acid, and sodium hydroxide, and then that gives you sodium chloride and water. Now, so let's say you are given this balanced chemical equation. Now, the first thing that you need to do in order to come up with the ionic equation is to look at the state symbol of each substance. If the state symbol is aqueous, it means that the substance dissolves in water. When the substance dissolves in water, they exist in ions form. So in this case, your HCl, you can split up because it is aqueous state. So you can split your HCl to become H plus and Cl minus. Okay, and then likewise for sodium hydroxide, you split them up, become Na plus OH minus. Now take note this OH. OH doesn't stand for oxygen, hydrogen. Of course, O stands for oxygen, H stands for hydrogen. But this OH actually is an ion by itself. It is a hydroxide ion, and it is one of the 5 polyatomic ions. So when NaOH dissolves in water, they will form Na plus, which is sodium ion, as well as hydroxide ion, OH minus. Okay, and then for sodium chloride, it is aqueous, so you have to split them up into ion, Na plus sodium ion, as well as Cl minus. And then lastly for H2O, the state symbol is liquid, so H2O is liquid. Liquid is not aqueous, so you don't split the H2O, so the H2O will remain by itself. Now at this stage, you have to identify the spectator ions. Spectator ions basically are ions that do not take part in the chemical reaction. They do not take part, meaning that they exist on the left hand side and then as well as the right hand side. So in this example here, you can see sodium ion exists on the left hand side and right hand side as well. So your sodium ion is a spectator ion, so you just cancel them off. If they are spectator ion, you cancel them off. Likewise for chloride ion, you cancel them. After that, you rewrite the ionic equation. And this will be your ionic equation. H plus OH minus gives you H2O. Okay, let's look at the second example. The second example, the balanced chemical equation looks like this. This is your sulfuric acid. React with KOH, which is your potassium hydroxide, and then that would give you K2SO4, your potassium sulfate, and your water. Okay, This is the balanced chemical equation. Now same thing, when you see that the state symbol is aqueous, you have to split them up into ions. So sulfuric acid, you have to split them up. Sulfuric acid consists of hydrogen and sulfate. So hydrogen ion is H+. There are 2 hydrogen ions, so 2H+, plus sulfate ion. Now, one thing to take note of for when you are splitting up the sulfuric acid is your hydrogen ion is H+. You cannot split it into H2 and SO2 -4 because H2 is actually hydrogen gas. Yeah, so in ions form is actually H+, and there are 2 H+. Okay, then for KOH, your potassium hydroxide, if you split them up, it becomes 2K+, because there is a 2 in front here, plus 2OH-, which is your hydroxide ion. And then potassium sulfate, if you split them up, become 2K+, plus SO2 -4. Okay, and then water, you have to remain as it is because water is liquid, it is not aqueous, so you don't split a liquid into ions. So this would be your equations after you have splitted up the aqueous, those substances in aqueous. Then after that, you have to look for the spectator ions, those ions that exist on both sides of the chemical equation. First thing is your K+, potassium ion, potassium ion. You can cancel them off. Likewise for sulfate ion, sulfate ion. So what is remaining is 2H+ plus 2OH- give you 2H2O. Okay, remember the state symbol. Okay, this step you don't have to write the state symbol actually, because this is an intermediate step, it's not the final answer. Usually for ionic equation we are only interested in your final answer. So intermediate step, don't waste your time by writing down the state symbol. So at this stage, you can see that there is a coefficient of 2 in front of each of the substances. So you can actually divide the whole equations by 2, and that would remove the 2, and that would give you H+ plus OH-, that would give you H2O. Okay. Now, take note that this equation, this ionic equation, this is actually your answer. This ionic equation and our previous ionic equation are the same. These two, this one and this one are the same, even though we are using different substances. Why? Because this is the generic ionic equation for all reactions that involve an acid and an alkali. So as long as you have an acid, regardless of what the acid is, as long as you have an acid that reacts with an alkali, regardless of what kind of acid, what kind of alkali it is, as long as it is an acid reacts with an alkali, the ionic equation would be the same. Okay, so this is the ionic equation for any reaction that involves acid and alkali. From here we can see that any reaction that involves acid and alkali basically is the reaction between the H+ ion and the hydroxide ion, the hydrogen ion and the hydroxide ion, to give you water. So this is something that you need to take note of. Now let's look at the third example as well as the last example. Now in this example we have Fe, which is iron, reacting with copper sulfate to give you copper as well as iron sulfate. So you're given this balanced chemical equation. So how do you come up with the Ionic equation? So I said already, when it is solid, you remain as it is. When it is an aqueous, you have to split them up into ion. When it is a solid, remain as it is. When it is an aqueous, split them up into ion. Then after that, whatever ions, whatever substances that appear on both sides of the equation, you have to cancel them off. Sulfate ion, cancel them off. Now these two, they are not the same. Fe2 plus and Fe, they are not the same, even though both are iron. But this one is iron, solid iron. This one is iron, ion. This one is an ion. This is not an ion. So they are different, meaning that you cannot cancel them off. So rewrite the equation and this will be your Ionic equation. Alright, so again, after watching this video, you can download the worksheet, try it out. Any problem, you can come back to this video again. Bye bye.